Hi everybody, this is Mr. Zarzak, and in this video I'm going to take you through how to do the geometric ray tracings for different types of mirrors. So let's get started. Alright, so first this is called the plane mirror, and I've got some candle out in front of the mirror. Okay, so the first thing I want to do is I'm going to start up here at the candle flame, and I'm just going to draw a ray, an incident ray, that just goes straight from the top of the candle, okay, to the mirror like this, and I'm going to do the exact same thing, alright, for down here at the bottom. Okay, so I have two incident rays that are at 90 degrees from the mirror, but if there was a normal line there, those would be at 0 degrees relative to the normal line. Okay, so that we say angle of incidence is 0. Those are going to reflect straight back. All right, so the reflections would just go right over the incident rays, so you wouldn't even see them. So what I'm going to do instead, right, is with plane mirrors like this, they form what's called virtual images. So I'm just going to take and I'm going to extend these lines here back behind the mirror. Okay, anything that goes behind the mirror, I make that a dashed line because that's what we call a virtual light ray. So the light doesn't actually pass through. We're just using these as reference lines to determine what we call image location. Okay, so those are imaginary. All right, now with a plane mirror, okay, we say what you see is what you get. The image location is the same distance behind the mirror as the object is in front of the mirror. Okay, so since I don't have a protractor, and many of you won't, okay, I'm going to show you how to do these without having to need a protractor. All right, if I take and I measure, to me it looks like if I go from the front of the candle to the mirror, that's about 4.5 centimeters. Okay, well that would be my object distance. Okay, that means my image distance is also going to be 4.5 centimeters. All right, so if I just go from the mirror there to 4.5, I just put a little mark like over here. All right, I'm going to do the same thing up here at about 4.5 centimeters, so something like that. Okay, those locations, that's where I'd see the candle. All right, and so I'm actually just going to make a quick little sketch. I'm sure you can do a better job than I can. Okay, so that's where the candle would be. Now technically speaking, okay, we're cheating a little bit. We're taking advantage of DO is equal to DI. All right, what we really have to do in order to determine image location is we need what's called convergence. All right, so I'm going to pick a different color. You don't have to do these in different colors. Okay, I just find that for the video, it just kind of makes it easier, all right, to see the different pieces that I'm doing. So I'm going to draw an angled ray up here. Now you could make it go down here, but I find that up at the top, it's easier to go up at the top, okay, and then down at the bottom. Now if I had a protractor, okay, I could draw like a normal line and try to measure this angle of incidence. I don't have a protractor, okay. I know that this one down here is going to reflect off something like this and something like that. All right, well I can actually get the exact angles of reflection without a protractor. So here's what I do, is I know where my candle is, it's back here. Okay, so I'm actually just going to line that up with my little candle, just like that, and anything behind the mirror, okay, is a dashed line. So if I just take and I just dash this back, okay, this little dash line is actually, I'm just going to use this for a reference and say, you know what, the light reflects off like this. And if I've done it right, okay, now my angle of incidence and my angle of reflection, okay, would be perfect. All right, and I'm going to do the exact same little trick. Okay, so again, we're just getting around the need to even use a protractor. Okay, it's technically the convergence of these reflected rays, so the little dashed black and the little dashed red lines, okay, that show me where the locations of the top and the bottom of the candle are. Oops, excuse me. Okay, but again, I don't have a protractor, but I can make these two angles here still look. So you can kind of see the angle of incidence here. You can see the angle of reflection there. Perfect. Okay, these kind of images that are formed with plane mirrors, these are virtual images because they're formed behind the mirror. All right, and this is right side up. You see that the top of the candle, okay, the convergence of those points come from the reflections of the rays we drew from the top of the candle. Same for the bottom, see? All right, next out of this is what we call the convex mirror. All right, so first thing you're gonna do with the curved mirrors, okay, is you're gonna take, and we don't wanna deal with that curvature. Okay, the ray tracings work regardless, okay, and so we can make this work out nice and perfect every time without a protractor. We draw that little vertical guideline. It's almost like we're just drawing the origin of the XY axis where we're just straightening out the Y axis, all right? So for all of these curved mirrors, all right, the first one I always draw is a ray that is what's called parallel, okay, to this thing that we call the principal axis, okay? So this is my incident ray that's parallel to this thing here. We call this the principal axis, okay, and that's my focal point. Okay, so for a convex mirror, a ray drawn parallel to the principal axis is going to reflect away from the focus point. So what I do is I line up my ruler here, okay, along the focus point, Okay, and these I'm going to need to drag back, so I'm just going to do that now. And then anything behind the mirror is dashed. Anything out in front of the mirror is solid. Okay, so 1, 2, and 3. All right, and notice that it intersects right at that like dashed line. Okay. The next thing I'm going to do, all right, is I'm going to draw a second ray. I'm going to start at the flame of the candle. All right, just like before, I'm going to aim right at the focus point. So see, like this, I'm pointing at the focus point, okay, from the top of the candle. And I'm going to draw an incident ray, okay, but I'm going to stop it right when I get to where the dashed line is here, okay? A ray that is drawn that is in a line with the focus point, when it reflects in a manner that is what we call parallel to the principal axis. See, so this actually bounces off the mirror like this. Okay, and so if you look at the red and the blue reflected rays, these diverge. Okay, diverging light rays, okay, form virtual images, and virtual images are behind the mirror. So I take and I drag that blue reflected ray behind the mirror with a dash line. I get this point of convergence here. Okay, that's actually where we're going to see the flame of the candle, but first things first, there's a third ray I'm going to draw. Okay, and again, I'm going to start up from the candle flame. Okay, I'm going to put my ruler right where the principal axis, okay, is bisected by that little vertical dash line, and I'm going to draw an incident ray. Okay, now this makes a little natural angle of incidence, okay, and so I know it kind of reflects off like this. I need a protractor to measure it. I can get around that, okay, by knowing about this convergence point here. See, so like if I take my ruler and I line it up with that little convergence point, okay, I can draw the reflected ray, okay, and now my angle of incidence and angle of reflection are perfect, no protractor required, okay. I'm going to take and I'm going to drag this one back behind the mirror as well, just so I can see that it crosses this location here. And it's that location here, that's where I'm going to see the candle. So like the flame of the candle is here, okay, and then the base of the candle is here. So like we see images here that are always going to be a little smaller. We're still behind the mirror, okay. Images that are behind the mirror are virtual images, okay, and our image is going to be right side up. All right. So these expand your field of view, okay, so they're really good for like blind spot mirrors and security mirrors, all right, but the cost of that is everything gets shrunken down to a smaller size, all right. Going on to the back side, all right, so I'm just going to throw that on there. Okay, this is the two cases that we have for the concave mirror. Okay, so the first thing I'm going to do for this is when the object is at a location that's greater than the focal length. So this would be like for object distance, that's the distance of the candle to the mirror, is something bigger than the focal length. All right, I'm just going to draw that vertical dashed line. Okay, and I do that for all of these, all right, so that the geometry comes out right. All right, first ray, switch into red. Again, you don't have to do it in different colors. It just kind of makes it easier to see, to track what we're really doing here, which is we start with a ray drawn parallel to the principal axis. Okay, a ray drawn parallel to the principal axis, when its reflection is going to be in line with the focus. Okay, and there's the focus. All right, so I'm going to take and line up my ruler with the focus. Okay, and draw the reflection right through the focus. All right, notice the focus is on this thing that we call the principal axis. All right. All right, so the second ray that I'm going to draw, I'm going to do that in blue. Okay, the second ray is always lined up with the focus point. All right, so if I take, and again, the incident ray is lined up with the focus point. Okay, with the concave mirror, the focus point is out in front of the mirror. Okay, and so I can draw it actually through the focus point on its way to the mirror. Make sure you go to the dash line, not to the mirror. All right. The reflection of the ray that goes through or in line with the focus point reflects parallel to the principal axis, okay? And so the red and the blue reflections actually converge out here in front of the mirror, okay, which is why this is going to form what we call a real image, okay? We'll get to that in just a second. All right, the third ray, I'm going to do that one in green just to stay consistent with my previous, okay, diagram. Goes from the candle flame down to where the principal axis, okay, the principal axis meets the center point of the mirror, so it's like the origin of like my XY axis. Okay, and like we've got a natural normal line here, so this would be my angle of incidence. Again, I need a protractor to measure that, but I can get around that because I know that this reflected green ray, okay, is going to go right through that spot where the blue and the red ray reflect. So see, angle I is equal to angle R, no protractor required. All right, so this convergence point shows me where the candle flame is. Okay, the base of the candle is on the principal axis, okay, which is why for the case where the object is somewhere bigger than the focal length, the image that's produced is inverted or upside down. Okay, it's also out in front of the mirror, which makes this a real image. All right, that is upside down. Okay, now this is the only case so far that we've seen with the real image. It's going to be the only one that's on the quiz. So when you're studying, just remember that this is the one that produces the real image. Everything else is virtual. And this is also the only one that's upside down. All the other ones are right side up. Okay, so that's the way that you should think about it or should study. Once I put the object at a distance less than the focal length, so we would say that the object distance is less than the focal length, okay? The ray tracing, or the result of the ray tracing, turns out a little bit different. Okay, the steps that I do are kind of the same. I draw that vertical dash line, so it's like I'm creating like an XY axis where the origin is at the point where the mirror hits the principal axis. Okay, and so just like I did with the previous two cases, the first ray that I'm going to draw is one that is incident parallel to the principal axis. Okay, so I start at the top of the candle flame. Okay, and I take it all the way to that dash line. Okay, don't stop it at the mirror. This is so that the geometry of this works out. Okay, a ray drawn parallel to the principal axis reflects through the focus point. Okay, just like it was up here. All right. Now, the second ray, I'm going to do that in blue. Okay, the second ray is in line with the focus point. Okay, so if I put the ruler with the candle flame and I line this up with the focus point, okay, incident light travels to the mirror. See, so I'm actually not going to draw anything back here. I'm just using this to get my angles right. Okay, I'm going to draw that incident ray up to where it hits that dash line. Okay, and because it's in line with the focus point, anything in line with the focus point will reflect parallel to the principal axis. So this is actually going to bounce off the mirror straight back like this. Okay, now notice that the red and the blue, these lines are now diverging, which means that they're never going to come together in front of the mirror. All right, it's the extensions of those reflections. They appear to originate at some point behind the mirror. So I'm going to take and I'm going to extend these back, okay, with dashed lines. Those are virtual rays. They're imaginary. They're not really there, okay? We just use them to determine image location. So these reflections appear, okay, to originate at some spot back here. That's the location. In fact, that's where we see the image, all right? Before we draw anything, we got to do our third ray, okay, which goes from the candle flame, okay, to where the center of the mirror meets the principal axis. Okay, so I got this big angle of incidence. All right, now I'm trying to estimate. We know it's going to bounce this way. Okay, I would definitely need a protractor unless I know the tricks, and here's the trick. All right, put your pencil right here. Okay, put it to that line. Dash line behind the mirror. Okay, and then there it is. Angle I is equal to angle R. Okay, it's the convergence of these three that show us where the candle flame is. All right, the base of the candle is on the principal axis, okay, which is why when we're inside the focal length, okay, instead of an image that can be projected like a projector, okay, well here we're getting big magnification. It's a virtual image because it's behind the mirror, all right, but because it's right side up and really large, here we'd use for like a magnifier or like a makeup mirror or something, okay? So that's it, that's the cases. All right, hopefully that helps with your homework. All right, don't forget to label anything. Go back and study this because you'll need to do it on the quiz from memory. All right, Mr. Zardek saying thanks for watching. Bye.